going to talk about the work performance benchmarking for pavements. This is what we developed. 4 things. I'm going to tell you what's the motivation to develop such a tool. Presentation of the designed PMS window, the actual window that have been developed. Some demonstration and capabilities of that window, and some real-life examples that we've done so far. About the motivation, for many years now, Transport Quebec, which is our name, connected many performance benchmarking, but for research and development projects, like new materials, new equipment. So we do tests to ensure that they are working well. But it's done on small sections, 300 meters, 900 feet, I think. So pretty small. And we collect data manually. So it's really project size projects. Very few performance benchmarking was done on usual pavement contracts, actual contracts, once they are completed. So it's done. All right, let's go to the next one. We knew that we need a tool to benchmark the performance of all the road contracts over time. The thing being that we want to identify what impacts the performance of the pavement once the contract have been done. In the end, we want to know what made the pavement perform well to repeat those good practices. And if the pavement doesn't behave well, avoid repeating the mistakes. But we have to know what went wrong. So that's the big idea of that. We have a good news. Since 2000, we measure every 2 years, at least every 2 years, reliable pavement condition data all over the network with high precision equipment. Actually, that's the same laser equipment than Kentucky presented yesterday. With a high quality control, we ensure that we have good condition data. So we measure at least every 2 years, IRI, of course, the rotting and the cracking. Cracking globally and identifying transverse cracking, fatigue cracking, so all the information. And we are very proud of that. We also record the network contracts that we carry out each year with, again, a high quality control. We know which treatment have been done, where, what material have been used, the thickness, all that stuff. So, combined with the road network characteristics that we already know, that we already have, and for that information, we can consider it as a massive data set. I think you call it big data also. So, a huge amount of information and data. So it was time to transform data into information. I like that quote. I really like it. We have a lot of data. Let's make talk that data. PMS have been the obvious tool to do that. We designed a mock-up inside at the Transport Quebec, and then we asked AgileAssets to make it a reality. And they did, actually. It's live since last December. So it's a pretty new window, but it is. And we made it accessible to all PMS users. However, so far, it's more the central office which use it. But the more and more we talk about that new window to users, they will, I'm sure, use it. And one concern that we have, we'll make sure that everybody share their findings. So, like I said Tuesday, we have 12 districts, 12 small MTQ, Small Transport Quebec, in a big Transport Quebec. So we want to ensure that what a district finds, they can share it to others. All right, let's switch to the presentation of the actual window. The new window has 3 tabs. The first tab that's the simplest one. That's for creating a performance benchmarking project. We call it a project to see the performance. So the system assigns a number. The user can put a description of the project, what's the purpose of the performance monitoring. And the system also records the user name and the date. Pretty basic. Second tab is the one where we select the contracts that we want to study. I call it the scope. The basic idea is to compare 2 groups of contract of a road work contract. I'll show it in detail later. The third tab, is to actually generate the performance graph. So show the actual performance of information for the contracts that we selected prior. So that's the basic idea. Select what you want to see, and then you see the result. So, second tab, the scope. You see, let's move. We have 2 sections, 2 groups, in fact, the group 1 and the group 2. So using a filter, using any contract information that we already have, you can select any contract that you want. And then you click the select button at the left side. You do the same thing with the group number 2. That's the same way to do it. And the contract information that can be used to define those groups, all the information we enter in the system each year. So we have the treatment, of course, the equipment that have been used, quality control measures that have been used or not, like infrared thermography. If we have an IRI requirement on the contract, everything is recorded. Maybe it could have an impact on performance, so let's keep that. The year the work has been done, of course, date of work completion, in which region, functional class, the materials, the type, the source. Sometimes that's interesting information to have. The thickness that have been put in place. Pavement condition before work. I'm pretty sure we can suspect that it has an impact on the performance of the work. And traffic level, ADT, percentage of truck. So we have a lot of information on all the contracts that we do each year. Massive data, I told you. Here's some benchmarking example that I can tell you right away. So we have 2 groups. For instance, what's the performance of a specific contract compared to similar contracts that have been done, the same region, and similar contracts. So on group 1, we will select that contract that we want to compare to group 2, all the treatment, the same treatment, same materials, the same region, and then we'll compare the 2 performance. That's one example. Second one, what's the impact of performance of asphalt laying when the temperature is cold? I'm pretty sure you know that in Quebec, the temperature is pretty cold in the winter. So we have a rule not to put asphalt after November 1st. But if we do, does it have an impact on the performance? And if yes, how much? So that's a tool that can answer that question. So we will compare the contracts that have been done before November 1st, great, to the one that have been done after November 1st. And we'll compare the 2 performance. Other examples. What's the impact of performance on using material transfer vehicle, a new equipment? So yes or no, you compare yes and no with similar situation. What's the overall performance of asphalt overlays done in a region, and that the explanatory variables of those who underperform. So let's take all the overlays that we've done and see, is there some that underperforms? And then let's try to explain why. In that case, we'll use only one group because we don't know what are the explanatory variables yet. We want to discover that. So we'll only use the first group and leave the group 2 alone. And if we see underperformance, let's dig deeper. So that's the idea. I would like to add another example. One region guide told us he was planning a rehabilitation on a highway with a pretty bad condition pavement, like a lot of cracking. And the PMS recommendation on decision trees was full demolition. So get rid of that pavement and build a new one. And the guy said, well, I think that simply milling and reinforcement, so a thick new layer of asphalt over that could do the job. I'm pretty sure 10 years. 10 years will be fine. So we did double check that with the tool. And actually, we selected all the milling plus overlay, thick overlay on similar condition pavement. And with the historic data, we saw that it's more 7 to 8 years prior to get back to a fairly deteriorated pavement. So we told the guy, well, actually the performance of that treatment, if you do that, you can expect only 7 to 8 years. So you see the kind of questions that can be answered. Now, the third tab, the results, that's the graph one. So the user can first select for which performance index he wants to plot the data. The most current one is IRI, of course, but let's check rotting, cracking, transverse cracking, or fatigue cracking. So any PI that is already in the PMS can be used. Second choice the user have to do is, do you want to plot the average and or individual display? So each dot is actual data that have been measured on sections covered by the contract. So you can, this is an example of you have both the average and the individual dots. Is there any? No, the other fields are for information. Like in that example, there is 2 contracts in group 1 and 2 in group 2. So that's a fairly small groups. And on the graph, so all dots, like I said, are PI versus year. So each year that we measure data, it's shown on the graph. And also at the bottom left, you have all the data that have been used to produce that graph. So you have the PI dash year, but on a more data form, which is exportable. So we can put it in Excel and do more things. So this is how the window works. That's pretty simple. So now I would like to show you some real-life examples. I've got 2. So the first one is contract versus similar contracts. That's the first example I told you a few minutes ago. So we want to compare the performance of specific contract with other similar contracts in the same region and similar condition. Let's compare the comparables. All right, we want to do that. So first, let's define a scope. Well, we create one project, easy. Second tab, let's set up the scope. So that you recognize that filter tool that we already have in the PMS. So on the first group, we select the contract we want to follow, and the second one, all the similar contracts, using a filter. And this is what it gets. So in red, we've got the actual performance of that contract, and in green, the average performance of similar contracts that have been done in that region, and all the dots. So first thing that we can conclude on that is that the contract performs generally better than the other contracts. Yep. The red line is over the green line. And also there are few outliers, call that. Interesting point here. It went very bad. And at the opposite, some sections perform very well. So that's interesting to see that and to dig, to understand why it did perform so well. And let's do the same thing every time. Cool. So the conclusion, yes, perform better than average. Great. But other question came up, like how does it compare to the current PMS performance model, the reference one? What are the explanatory variables? It performed better? Great. Why? That's the most important question to answer. Unfortunately, it was impossible to answer with the current tool, so the current 3 tab, but it gave us an improvement idea. And I'm going to show you that idea with the second example. Second example is performance explanatory variables. So a caller called us a few months ago. Called Monica, actually. And he said, oh, you have a nice new performance monitoring window, because we gave training to them to show them, oh, let's look at the new tool. So he called back and, oh, good job, yeah, so it looks great. Now, can you tell us the overall performance of asphalt overlays that we've done in our region? Sub-question, because what are the explanatory variables of those who underperformed? They knew that some contracts underperformed. They want to know why. And why are the explanatory variables of those that overperform? Two ways. Let's do again let's repeat the good things and stop doing the bad things. All right, let's challenge. So, create a new project, and now we create only one group. We will use one group. So all the contracts in that area that are overlays, let's select all of that. And the graph, the result graph that it gave us was that. So we have a cloud of dots. Some obviously doesn't perform very well. Some are pretty good. And here's the average. Great, but how do we answer the original question? It's hard with that graph. So the idea, actually it's Monica's idea. Let's create a 4th tab that will contain for each section within the performance benchmarking study, in fact all the road portions that have been covered with the contracts, let's put it all the information that is already in the PMS and that could be explanatory. General characteristic, region, functional class, traffic, etc. Contracts information, PI before work, treatment that have been done, materials, and condition data. So all the PIs that have been measured over the years on those sections. Let's put it in a window, in fact, the tab. And to make it talk, we use PivotChart, pivot, that's the way to pivot chart feature in Excel. Because that feature in Excel, we can see individual sections performance curves, not only dots, but the curves. I'm going to show you an example of that. We can add PMS performance models on the graph too, so as a reference. And mostly, we can add and remove dynamically elements to find explanatory variables, which is the big question that we want to answer. So that's the famous fourth tab, which we call detailed elements for the performance. So in there, we have each section that appears for each year, and we have the condition that evolves over the year. So that's a massive data to start with. But all the information is there. So this is data. Now we want information from data. And here it is. So you have a screenshot of the Excel pivot chart. So on there, you have all the lines, all the actual performance of all the sections for the contracts. In light gray here, you have the performance curve, the PMS performance curve as a reference. And you have all the variables that are available to check. The first thing we can see now is that, I'm going to show you on the next slide. So individual sections and PMS predicted performance model. Yeah. So on the next slide, oh yeah, elements, everything is there. Okay, here it is. So on the graph tab, the third one, we have the cloud of dots. And now in Excel, instead, it's shown with actual curves. The difference, look, we can already see that some sections are performing better than the normal performance curve and the model, and some are behaving worse, way below. So that's the same information. You see the dot there, but it's underlined. So that's interesting. Something there makes that some sections perform well and some not so well. So that's the way. And so far, it's under investigation right now. Monica is working on that. And what we found, surprisingly, is that one of the item that we found is the region. In fact, the smallest region. It's almost like cities or areas. So when we select, so all those contracts are located on some region. So that's the item that we saw. Of course, it doesn't make sense like that. I mean, the region cannot explain why some contracts didn't perform so well. We suspect that there is something under that. And maybe that's the material source. That's what we are investigating right now. So maybe that's the source of the material, because those contracts doesn't have any problem. So there's something there. So we have to dig manually. So Monica, uncheck, see if we can explain those two groups. So far, that's the region that is the most significant element to explain that behavior. Conclusion? Transport Québec has the maturity, and we have a lot of data, maturity to exploit all the information that we collected on our pavement network over the years. The drivers to develop a tool for benchmarking the performance of all the road network contracts over time was identify what are what impacts the performance on those pavements, and in the end, repeat the good practices and avoid repeating mistakes. That's the main goal of doing such analysis. And one interesting fact is we had an unexpected side benefit, because when we begin to use all those data, it helps to identify some missing or bad data. For instance, missing contracts. We saw some performance going up alone without any contract. Suspicious. And what we found is that a contract was missing. It hadn't been entered in the system. So we can quality control even more than before because we use the data. So that's interesting side effect. Like I told you, it's only in production since last December, so it's pretty new to us. We are the beginning process of doing work performance benchmarking using this tool. However, we already foresee positive spin-offs, like transform data into information. Told you I like that code. We realize things with that. It's come up to our attention, and we can share that information. Share it from central office to all the districts and between districts. We can improve our ways of doing things, take better decisions. Remember the example, the guy who thought that treatment could last 15 years? It's more 7 or 8 years. So maybe that guy will take a different decision because now he knows that. And in the end, we'll extend the pavement service life, of course, and optimize investments on our pavement network. So that's a good thing. Let me finish with an open question. I'm trying that. Remember, Monica has to select manually each element to see if it can explain the performance that we have. But artificial intelligence maybe could help finding explanatory variables itself, avoiding to click on unclick manually. And AI is pretty trendy and it's there, so I think it could make it even more interesting to get information from all those data using AI. So that's the question I would like to ask you what you think. So, merci beaucoup. Thank you very much.
Thank you for that, Martin. We can now take some questions from the floor. If you raise your hand, I'll bring the mic over.
Very interesting presentation. I was just wondering if you all have started a catalog of good practices as they influence each performance index.
If we start to?
Make notes and publish papers or anything about good practices by each performance index, how it influences each performance index?
Not yet, yeah. We are the beginning of the process of doing such performance monitoring studies, so not yet, but we will. We want to share that information within the agency, but let's share it with everybody. Yeah, that's our plan. Yeah, okay.
Hey, fantastic. It was a really great presentation.
Thanks.
For the benefit of the other agencies in the room here who are struggling to get good, reliable data from their field folks to do that, can you give any insight into how you gain success to get what you said is good, reliable data to feed this model? Because that is really the big missing link for a lot of folks. That's right, and that's the basic. We can't do that because we had good condition. Good data. Bad data, bad results, for sure.
For the condition data, we use fully automated equipment on a vehicle. So it's laser, it's controlled, severe quality control. So that part is now pretty easy. The contract history, it's another story. What we did, first, we named a person on each of the 12 territories that is responsible of each file entering the system, all the contracts that have been done in the last summer. From crack sealing to new constructions, every contract that have been done. So there is a person identified. Second thing, I think, would be leadership. So high bosses told that it's important for Transport Quebec to have that information. So guys, you have to do that. You have to find time to enter that. And we have a meeting table. So each year we met those people and we collect their requests. So we exchange. So we have a community. So they are supported. That's the main things that I would like. And quality assurance, of course, we make win phases on that too. So that's the way it works. It's mostly based on trust, and so that's the way we do that. Yeah.
Just here.
I was discussing this with Martin, and another thing we're doing, not at Quebec, but in New York, we have a quality control process to bring in the data, and automatically it spits out a report because they have in New York also automated inspection or monitoring of the pavement, and so if they see that there's an improvement and there's no construction history, the system will generate the report to say, hey, to go back to the region and say, how come this happens, and vice versa. If they say, oh, we had a construction and the score doesn't improve, so there's possibilities within the system to help you out. But I think Martin's are the key factor. We're just a tool to support the process.
Yeah.
I think it seems like culture is a big part of it.
Right.
You gotta have a culture
Right.
you want to do.
Let me give you another piece of advice. Make them use the data. That's our next challenge. All the project managers, they own that information, so let's make them use that information. At the beginning, they were only providers. So, you want that information, and go, okay. Now, there is tools that you can use, they can use it themselves. So now they do it for them and for others, but so we make them use that data. So it's
This is a really very good topic. I think we all need to learn why some of the contract goes well, have very good performance, and others not really so well. So figure it out exactly the reason why. And I saw you present a chart, which is really interesting to me. Some of them really perform really well, others not so well. And then the goal is trying to figure it out why. And then you have this performance model, which are really kind of close to the better performance part. So I assume when you have the model in the system, and then that was based on some of the historical data, maybe some of the explanatory variables, so can you share some of the lights, the reason why, what kind of a models you used before, and then what you consider as your explanatory variable?
So far, the PMS performance curves are computed from actual data. So that's why that was pretty much in the center. So that's average, average performance. We have a statistician who is responsible of doing those performance curves, and she told me that she's planning to change the families. We have a performance curve for each family. With the results of those studies, maybe the variables that we use to define those families has to change. Maybe there's other factors that are more relevant that we could use to define families. So another side effect, in fact, comes in my mind, will be better performance curves because better families of pavement.
Absolutely.
Makes sense? Yeah. Now that's really exciting. It's few months ago, and we already see all the power and the impact that it will have on our agency.